method, actually, when we solve, if you remember D'Alembert principle, it was just basically, if you see, what was there? There was no time or anything, or velocity was not there in anywhere. Now, if velocity is given, then we can solve such problem by using work energy principle. Work done by the force on a moving body is defined as product of force and distance move in the direction of the force. Let's see. HUD. Okay, so what is mean by work first will come across. So it is a distance multiplied by force in that direction. Okay, now let's say one body moves a distance of s. Okay, one body moves a distance s. Let's say forces P1, P4, P3, and one force which is acting opposite of that motion as P2. Okay, so P1, P2, P3, P4 are the forces acting on that body. Body is moving in this direction. Okay, so what will be the work done formula for each force? Okay, so force, because of force E1, because of force P2, sorry, because of force P3, and because of force P4. What will be the forces? So how much distance body travels? Distance travels is s. So let's say this force P1 is acting in the same direction as that of the motion. So P1 s. If you see P2, the force P2 is acting in opposite direction of that of the body motion. That's why when we write work done, it will be minus force into distance. Now if you say the P3, it is acting vertically. Now you tell me body, does, does this force P3 will affect this motion of this body? No, because it is acting totally perpendicular direction. That's why there will be work done is equal to 0. Then last one is, let's say P4 is making angle theta. Okay. Then what will be the force along the line of action, that is x direction? P4 cos theta. So P4 cos theta. And how much distance it travel? So total work done. This is just illustration how you can calculate work done for different forces. Okay. Now we have to use this for our work energy principle. So work done by force may be defined as product of component of force in the direction of motion and distance moved. Remember, last here we can define in another way. If force is acting at an angle, then work done is defined as a component of force in the direction of motion and the distance moved. Okay, if direction is opposite, then you have to add negative sign. Okay, let's check new unit of work done. Force is Newton and distance I will say meter. Okay, this Newton meter unit is also called as a joule. Okay, hence joule may be defined as amount of work done by 1 Newton force when a particle moves 1 meter distance in direction of that force. Okay, let's go to the next. Now our topic is work energy meter. Right? We define now work. Let's define work energy. Energy, we can in simple word, we can define as it is the capacity to do work. So what are the types of energies here in our science? I will not say in engineering, it will be in science. Okay. The first is heat energy. Second one, mechanical energy. Heat energy basically due to temperature difference. Mechanical energy due to force difference. Chemical energy due to chemical instability. Okay. So these are the types of energy which we come across in our engineering field. But in our engineering mechanics or our topic of interest is only here is mechanical energy. We are not bothered about what is happening with heat energy or chemical energy. Okay. So only we are going to look after mechanical energy. Now mechanical energy we can classify into number of types of energy, but basically I will first classify it as two energies, potential energy. Okay. What is potential energy? It is energy or capacity to do work or energy due to position of body. That means if you keep one ball above height h, okay, then this ball stores some energy and that energy is called as a potential energy. If you move your hand, this ball will go down with a due to attraction of gravity, and this all energy is called as a potential energy. Okay, its formula is weight into height, or in simple word, mgh. Next is the kinetic energy. Okay, so kinetic energy basically because of motion of the body. This is already you studied. I'm just refreshing that motion of the due to motion of the body. Let's say car is moving with a velocity of v meter per second. So kinetic energy is defined as half into mass into velocity square, half mv square. You know that. Now let's go for power. These are the basic term of science, but still we are going through it so that it will be easy for you to understand. So potential energy is mgh, kinetic energy is half mv square. Power next. It is defined as time rate of doing work. Okay, actually it is nothing but work divided by time, or work is nothing but joule, time is second. So its new unit is defined, that is called as a watt. Okay, so these are the all energies we come across work energy principle. Okay, now have you understood all those things? Let's go to the actual topic of work energy equation. Okay? Let's say one body on which number of forces are acting. Let's say F1, F2, F3, F4. Let's say weight acting on that body is W, and it is moving, this body is moving in X direction from point A to point B. Let's say small a be the acceleration, C be the velocity, and S be the distance. Now, what was the Newton's second law? Do you remember? In mathematical form, force is equal to mass into acceleration, right? We can write okay, let's say this body moves by a distance of ds. Okay, so we can write F into ds is equal to mass into acceleration into ds. Or we can write mass into this, we can write as acceleration, we can write as v into dv by ds into ds. How we can write that? Just see. velocity is meter per second into again change in velocity meter per second divided by distance is meter. So automatically this meter and meter will get cancelled out, and what remaining is meter per second square. That is nothing but acceleration. Okay, that's why we can write m into v. This ds and ds will get cancelled out. So what we get is m into v into dv. That is equal to force into. We are playing with same equation every time in different method. D'Alembert principle, we use direct equation. Now we are only converting this equation in terms of energy. Okay. Now we know that body initial velocity of body is u and final velocity of body is v. Initial displacement of body is 0 and final displacement is s. So let's integrate both equation from 0 to s, q to. So what we get, f into s is equal to m v square by 2 uv, or v square minus u square, or half m v square minus u square is equal to force into distance. So this equation is called as the work energy equation, since force into this term F into S, this term force into S is work done by the force, okay, which is we can write this equation as half mv square minus half mu square. So we can write statement that work done is equal to subtraction of kinetic energy at a final point to the kinetic energy at a initial point. Or we can write, please note down this equation, work done is equal to the final kinetic energy minus initial kinetic energy. Okay, now let's solve some problems on work energy method, and then we'll go to the last topic, that is impulse equation. For that, please note down a body weighing 300 Newton is pushed up a plane (30° plane by a 400 Newton force acting parallel to the plane. If the initial velocity of the body is 1.5 meter per second and coefficient of kinetic friction mu equal to 0.2, what velocity will be the body have after moving 6 meters? This is the statement in front of you. So what they are saying, there is a plane, inclined plane, on which one body having weight 300 Newton is pushed up, okay, by a 300 Newton force. Diagram is not given. Remember, you have to draw this diagram also. So one force 400 Newton is acting parallel to the plane, and if initial velocity is 1.5 meter and coefficient of friction be 0.2, then they are asking you to find out final velocity of the body when it moves 6 meter. Okay. So please note down this statement. We'll give 10, 20 seconds. Okay, done. Let's draw the diagram. So yeah, I will draw just below so that we'll get some space. Four hundred Newton force which is acting parallel to the plane. Then body weight is 300 Newton. So it will be acting vertically downward. Block is moving upwards, so automatically friction force will act in opposite direction, mu n, and there will be a normal reaction. Yeah, I am directly doing on that problem. You need to draw a separate three-body diagram for the block. Let's say summation of force facing. Now we have to decide first our axis. So I will consider this as the x-axis and this as the y. The only force which is at an angle is 300 Newton. So 300 sine side 30, 300. cos 30. Okay, so let's apply our equation one by one. Summation of forces in y direction is equal to 0. So what we get is 300 cos 30 minus plus n is equal to 0, or we can write directly n is equal to 300 cos 30. Now, this answer is, if we calculate, it will be 259.81 Newton. Okay. Now we know that frictional force is equal to mu n, which is equal to mu is given as 0.2 into. Okay, let it be. We will not calculate like this. We will keep in our. Now let's say what is initial velocity. Initial velocity is only unknown was n, so we calculated n. So everything was known. Now initial velocity u is given in our problem. How much it is? 1.5 meters per second. Displacement s is given as 6 meters. Okay. So initial velocity is 1.5 meter, displacement is 6. They're asking you to find out V is how much. Now let's apply our work energy principle. What is work energy principle? Work done is equal to what? Work done is equal to, or instead of work done, I will write force into displacement is equal to half m v square minus u square. Now, what are the forces acting on the body in the direction x direction? Only x direction forces will be considered, and no y direction forces, because body is moving in this direction. So, whatever forces in x direction, those forces only will be considered. Other forces will not be considered. Remember, okay? Let's one by one write those forces. So, first is a 400 Newton in the direction. See, now positive and negative will be decided by the motion. If the force is in motion, then it is positive. If it is against, then it is negative. Then minus mu n, see, 400 Newton, then minus mu n, then minus 300 sin 30, into displacement. How much displacement it is? 6 meter is equal to half. Now body weight is given W 300 Newton. Mass is not given. Weight is 300 Newton. So you have to find out mass by using W by G. G is 9.81. Remember. So weight 300 divided by 9.81 into P square minus 1.5 square. Okay. That is equal to 400 minus 0.2. N is just now we calculated how much? 300 cos 30 minus 300 sin 630 into 6, that is displacement, half 300 . So using this equation, we can calculate directly final velocity of body with this number of forces acting on the body. Okay, have you understood this? Now let's go to the next type in this problem, that is called as a connected body. Motion of connected bodies. Connected body means what? Connected by string. Body is connected by string. Okay. Now, for example, let's say one body of weight W1, another body weight W2. Both are connected by a string. If you draw a free body diagram, then you can show, let's say, bodies are moving in this direction. Then friction force will be act like this. Let's say P with the force acting on this body, which is pulling this whole system of connected bodies. Okay. Now, when a body is body, I'll say A and body B. Body B is pulled by force P by a distance of S. The other body also will move same distance with same velocity. Hence, initial velocity and final velocity and displacement are same for the both bodies. Now, out of these all forces, frictional force F1 will do some work. Okay, negative work, opposite work, but will do some work. Okay. Now, when you apply some connected bodies are there, what you have to do is you have to consider total body as one system. Total body as one system. And now you have to apply this equation. So what are the forces here? So F1 into S. See, direction of motion is opposite, so minus F1 into S plus forces acting on this body B, that is E is positive along the direction, minus F2 opposite direction. Then its weight W2 will be having two components. So W2 sine theta, so minus W2 sine theta. Let's say this angle is theta into S again. See, both are the displacement is equal to again half M1 V square minus U square plus half M2 V square minus U square. Remember, when bodies are connected, displacement are same and velocity also same. Okay. So this is the new equation when we apply work energy principle to the connected bodies. So we will solve one problem on connected body. It is very simple to solve such connected body problem. Okay, write down Determine the constant force P. That will give that will give opinion that will give the system of bodies a velocity c meter per second. After moving 4.5 meter from rest. Mu is given as 0.3. Okay, and they are saying pulleys are smooth. I will draw the diagram. Angle is given in terms of slope. Okay, so these three bodies are connected together, and 250 Newton body is pulling 1000 Newton and 500 Newton in direction. Now we have to draw a free body diagram of these bodies. So let's draw a free body diagram. First, it's different. So 250 Newton will act downward. Force P acting here. This body is moving it from right to left. So frictional force will act in opposite direction. Mu N1. I'll give N1. Then we will not consider bodies separately, but as a one body. If it is considered separately, then you need to solve too many equations at a time. So instead of that, we will consider all bodies together connected and we'll solve the problem using work energy principle. Okay. Then this is 1000 Newton acting downward. Frictional force will opposite direction. Mu N2. Let's say this as N2. Then this is 500 Newton. This is mu N3. N3. The total diagram we are drawn. Now we have to Find out N1, N2, N3, N4. Sorry, N1, N2, and N3. How to find out N1, N2, N3? What you have to do is consider separately bodies. First body, body A, body B, body C. So for body A, if you apply summation of Fy is equal to 0, then automatically N is equal to 250. There is no other force in Y direction. Then for body C, N3 is equal to 500 Newton. And for body B, this 1000 is classified as 1000 cos 60 and 1000 sin 60. So N2 is equal to 1000 cos whatever angle theta. Theta will be is given by 4 by 3 na. So tan theta is equal to 4 by theta is equal to tan inverse of 4 by 3. So from here you will get N2, N1 and N3. Then you can find out F1, F2 and F3 also. F1 is equal to mu into N1, that is 0.3 into 250. Similarly, F2, F3. Okay. Now we got all unknowns. Now we can apply energy principle, work energy principle. What is work energy principle? Is forces along the direction of motion only we will consider. What are the forces along the direction of motion? So let's one by one see. Force P, then mu n parallel. Okay, no problem. Then this frictional force, then 1000 sin theta, right? Then this frictional force, then anything? No. So these are the forces only we have to consider. So let's write down. P is the direction of motion. See, now we are not looking for right and left positive. We are only looking for the direction of motion. So P is positive now along the direction minus mu n1 minus mu n2 minus 1000 sin theta minus mu n3. These are the all forces acting on the body along the direction into displacement or distance. S is equal to, we can write m1 plus m2 plus m3 weight of all body divided by 2 v square minus u square. How we can write this? I'll go back to your connected body equation here. See, here half and vu square are common. So if you keep m1 plus m2 divided by 2, then v square minus. Okay. So this is the final equation. You can find out from this what is value of P. If you substitute all of this, you can easily get value of P. So this is all about work energy principle. One problem on normal and other problem on connected bodies we have completed. Now final will be impulse momentum equation. What is impulse is nothing but a sudden force for a short period of time. Okay? If a sudden force acting on a body for short period of time, then that force is called as the impulse force. Impulse momentum equation. If you check your syllabus of engineering BME, then we are almost completed. 99.99%. Okay. Go through your syllabus always. What we taught and what is remaining, you have to always check. Right? So first module, if you say, I'll share my screen. Wait. Your syllabus. If you say first module, we started with forces, then Lami's theorem, then beam support reaction, then friction, coefficient of friction, angle of repose friction, inclined plane, and last one is a ladder and wedge. So whole first module I have completed. Then second module is moment of inertia, then parallel perpendicular axis theorem, then MI of a built-up section. That also we have done. Now we have come to the next type, work energy principle. Just now we are done. D'Alembert principle and application we have done. Now we are at the edge of our completion. That is last equation. That is impulse momentum equation. From tomorrow onwards, Professor Pratik Savdekar will take your offline lecture and online lecture also. Okay, so he will start with thermodynamics, then manufacturing. If you remember, I have told you syllabus for your IT2. Do you remember that? So there will be one problem on centroid. So there will be one theorem will be asked out of parallel or perpendicular axis. Then there will be one problem on friction, whatever we solve in our class. Then there will be a centroid problem and a moment of inertia problem. And moment of inertia problem will be same diagram that of centroid. Okay, so first two question, three question will be easy. Moment of inertia calculating will be quite difficult, but I know you will solve it. No question will be asked for work energy and all those principles. Your third IT will consist of all second and third and fourth model. Okay, so let's continue with our impulse momentum equation, final part. total impulse momentum equation is a sudden force act at a small time of duration, then it force that called as a impulse. Okay, again we'll go to this Newton's second law. See, all three topics are based on one law, that is Newton's second law. We know that force is equal to mass into acceleration, and acceleration we can write as change in velocity with respect to time. Or we can write force into time is equal to mass into change in velocity. If you take an integration on both sides, what we get is F into T is equal to initial velocity u, final velocity 0. Initial time 0, final time t. So F into T is equal to m into v minus u. This this quantity force into time is called as the impulse, and impulse is equal to change of momentum. What is momentum? Mass into velocity, right? Momentum is equal to mass into velocity. So impulse is equal to change of momentum, right? So we are going to use this equation to solve problem on impulse momentum equation. Okay. So let's solve some problem on impulse momentum equation. Okay, right now. 20 kilonewton automobile is moving at a speed of 70 kilometer per hour when the brakes are fully applied. अरे यार. When the brakes are fully applied, causing all four wheels to skid, determine the time required to stop the automobile. Having mu of road is 0.75 and having u is equal to 0.08. Okay, first important thing is writing the quantity. We need initial and final velocity. So initial velocity u is given as how much? 70 kilometer per hour. Now we have to convert that into meter per second. So 70 kilometer is 1000 divided by 3600. That is 19.44. final velocity, when brake are applied, what will be the final velocity? V is equal to 0. Right? Now just imagine this is the vehicle. Okay. You apply a brake. Because of that brake, friction force is acting on opposite direction. Weight will be acting in downward direction. Then what will be the equation of impulse momentum? Force into time. Which force is acting in direction of motion? So mu n. So mu n into time. But mu n is acting in opposite direction of motion. That's why minus sign is equal to mass into P minus U. Now mu is mu is given as 0.75. If you say n using summation Fy of equilibrium, n is equal to weight of that body, right? How much weight is given? 20 kilonewton. So 20 into 10 raised to 3 into time is equal to mass is equal to 20 into 10 raised to 3, that is weight, divided by 9.81 into V is equal to 0 minus Q is given as 19.4, right? So applying this equation, you can directly get what will be the time required. So such problem will be asked for you in impulse momentum equation. Remember, okay? So that is all about some problem I will share with you for your practice. So I'll round up all those things and wrap up everything for first two modules. So I declare first two modules are completed 100%. For IT2, as you know, one problem will be one theorem. Out of two theorem, one theorem. Second will be friction problem from your notebook. Third will be centroid. Simple problem. What you solve in notebook, simple than that. And on based on that same centroid, there will be problem on moment of. Okay. So that will be the IT2. IT2 only, I will only correct. So you have to come to me for IT2 marks and all those things. Okay. If you have any doubt or anything also, you can come at any time. Try to concentrate on third and fourth module also, because those are theory module. See, those who are experts in mechanics, who becomes expert, I know, for them, on 1, 2, 3, see. This third and fourth module is basically, and this is wholly. Now you decide in which field you are expert. Okay. Normally, I will say means this is normal pattern. Topper will get out mark from here, and some they will lose mark from here. Yeah. Because they consider this as each part. And then if you go for passing percentage, then you need to concentrate on third and fourth model because that is theory part basically, and you can get out almost 40 marks out of 50. Okay, so concentrate more those who are not able to solve problem, difficult problem on first and second module, concentrate on third and fourth module. Okay, that is all for today's lecture. Take care, stay safe.